Modular arithmetic, sometimes called circular arithmetic, is an interesting variation of ordinary arithmetic operating on the integers. So modular arithmetic is modulo a particular number, so let's consider the case of modulo 12. Then we can represent it by the numbers on a clock. The only difference is that we start at 0, which I think is more natural than starting at 12. So you think of 1 o'clock, 2 o'clock, and so on around until 12 hours later we're back at 0 again. So we deal with the numbers 0, 1, 2 up to 11, and then 12, which is congruent to 0, or sometimes we say is equivalent to 0, or sometimes we may even say is equal to 0. And then 13, which is congruent to 1, and that is congruent to 25, because 25 is 2 times 12, that's twice around the clock, and then we have 1 extra to go to make 25 from 24. Notation that we read as is congruent to or is equivalent to. And sometimes we write 25 is equivalent to 1 mod 12 if it's not clear what we're taking modulo with respect to, or even 25 is equal to 1 mod 12. Addition and multiplication are defined in the natural way. So I give the example here, 8 plus 7 is congruent to 3. So 8 plus 7 is 15, which is, if I go around like that, 12, 13, 14, 15. So 8 plus 7 is 15. 15 is 12 plus 3, so it's 8 plus 7 is congruent to 3, modulo 12. Sometimes we write 8 plus 7 is equal to 3, modulo 12. So in effect, the only numbers we deal with are 0, 1, 2 up to 11. And 2 times 8 is congruent to 4, modulo 12. Well, 2 8s are 16, and 16 is 12, which takes us back to 0, plus 4. And sometimes we'll write, consistent with our previous notation, that 2 times 8 is equal to 4, modulo 12. Another notation we use circular plus. So we say that 8 circular plus 7 is equal to 3, modulo 12. So it's a slightly different type of addition from the usual addition. It's the ordinary addition, and then we take the remainder after dividing by 12. Sometimes we'll write 8 O plus with a 12 down here to emphasize that we're doing addition modulo 12, and so on. Now, most of the usual properties of addition, multiplication, and in fact subtraction hold modulo n, but we can't normally divide except when n is a prime. So then we do have multiplicative inverses and we can do division. So 3 times 5 is equal to 1, modulo 7. So we can say that the inverse, 3 to the minus 1, or 1 over 3, 1 divided by 3, is equal to 5, modulo 7. And we can write it this way, 3 to the minus 1 is equal to 5 modulo 7, 5 to the minus 1 is equal to 3 modulo 7.